This video is to talk to you about example 2 for linear regression. So what I did was I started again by taking this data and putting it into my Statlet. So I come right here to two quantitative variables. Okay, I typed in my data and it ends up looking like this. I've got the height of a tree in feet and the diameter of the tree in inches, and begin analysis. You're going to get your scatter plot, correlation, and your residual plot. I want to talk to you for a second once again and make sure that you understand what a residual is, and I want to try to draw it for you. Hopefully I have a little bit more time in this video. So a residual is how far off our actual point, our actual data is on the regression line. So let's just pick a point and say we're talking about this point right here. You see how it's a little above my regression line? And if I were to be able to take and draw this straight down, I'm not very good at drawing straight, right down to my regression equation, okay? This vertical distance right here is the same vertical distance right here. How far is that point off of the regression line? That's what a residual is, okay? And that's what you're gonna see every time you look at residuals, all right? So that's what I am looking at. So let's go back to my example now. All right. So again, I cut and pasted this, this scatter plot from Statlet. Make sure that you type in good variable names with units of measure, because that's part of what you're graded on here is the good communication on this graph. This runs just like the last example, okay? This is not quite as strong a relationship. R is not as close to 1 as it was before, okay? The relationship is still positive and is still strong, just not quite as strong as the last one. My coefficient of determination is R squared. If you were using software that didn't give you R squared, you can find this simply by squaring R. So you can put 0.819 squared in the calculator and get R squared. 67.1% of the variability in tree diameter can be explained by the model. So whatever's left over, the other 32.9% is other values, things like rain and environment and all that kinds of thing that would also affect the diameter that the tree would grow. Okay, here's my regression equation, again, replacing X and Y in my equation from Statlet. Okay, my slope, I predict an increase of about 0.48 inches in diameter for every additional foot of height that the tree has. Now watch carefully, because sometimes your y-intercept doesn't make any sense. It doesn't make sense to say that at 0 height, I have a diameter that's negative. That's silly. But you got to remember that we're not going to have a tree that's 0 inch or 0 feet tall either. So if 0 doesn't make sense for X, your y-intercept probably isn't going to make sense either. It just happens. Okay. When we make a prediction, we're going to have to put 80 in there. Okay, and run it through. For a tree that's 80 feet tall, we predict a diameter of about 14.3 centimeters. Okay, remember this is a model, so it doesn't fit the data perfectly. This is the model that best fits the data we have. I can find the residual again by hovering. Okay, it's positive this time, so that means that our actual value is a little above what we would predict. And then again, this residual plot is just copy and pasted from Statlet. I want to see a nice random scatter there. If I see a curve, that's not a good thing, okay? Because that means our data really isn't linear. We need to do something different. Thanks for watching example 2 video.